right, good afternoon. Thank you all for joining. Do we have any confirmation that we have audio streaming out? Can someone raise their hand online?
Yeah.
All right, perfect. Well, good afternoon. My name is David Cocker. I'm one of the researchers from the University of California, Riverside and CSERT. Very grateful that you join us here today, both in person and online. We have a nice slide deck to go through to give you an idea of what our goals are here, some objectives, get community feedback. Before I get going, I really want to just let you know how grateful we are as researchers to have the opportunity to conduct this research out here in the Bay Area, and for all the support from the many partners that provided the funding for this work. That includes the Coalition for Clean Air, East Yard Communities for Environmental Justice, the Natural Resources Defense Council, the San Pedro Peninsula Homeowners United, San Pedro and Peninsula Homeowners Coalition, and this is administered by the Rose Foundation. I have up here, and at the very last slide, you'll see it again, both an email address that if you want to contact us, it'll be monitored regularly, as well as a website that is up where information will start to appear as the study progresses. But the website is also up, and it'll give you the opportunity to provide feedback, comments, or suggestions to the study. If you're online or if you're here, if you could please check in. The idea of getting you checked in is if you do provide your email address, we will be able to email you a link to this presentation, as well as additional information as the study goes forward. And this QR code will appear multiple times throughout as well. All right, real quick, because this is a hybrid meeting, I'm going to put up the meeting rules. Meeting is being recorded, so we want to make sure that everyone online also understands this is recorded. All Zoom participants are muted. We have a monitor in place for questions from Zoom participants as we go through, and we're going to have a number of different breakpoints to ask for questions as well. So please enter your comments into the chat. They'll be monitored for those breaks. Again, a link to the presentation and Zoom audio will be provided to all participants that provide an email address. The presentation is going to basically be in 4 sections. We're going to stop for clarification after each part. Ideas and feedback we welcome at the conclusion of the presentation. So when we're talking about this, we're here today more on the community engagement portion of this project. And this is the types of things we want you to think about as we're going through the presentation today. First thing that we need is you to watch closely at the study design as we're going through in case you have feedback or suggestions that arise. Right? There's a real important aspect to any type of work here, the community, that's called citizen science. And we'll be addressing what some of these questions might be on there for how we might use a website to better do this, how to improve community engagement, information that you would like to see and how you would like to see it, information that you would like to be able to access on a website, how else to make the information more accessible to the more general community, how to encourage consistent community observations from repeat observers. We'll talk about some of the opportunities there. We aren't here every day, you are. How do we get the word out? How do we get information for observations that you might make and that might help drive what we do? Overarching goal of this is to basically close critical knowledge gaps, to provide frontline communities and regulatory agencies the information needed to advocate for prioritizing public health in policy-making decisions related to the impacts from the port activities. The goal of today's meeting is to inform you on the air quality study that's going on, the individual goals of the different parts of it, as well as provide an opportunity to get feedback here. So that on the program that's focused on OGV emissions, ocean-going vessel emissions, and frontline community air quality impacts. The project team is actually fairly large. we have a number, I'm going to show you a couple pictures and really go into this in a moment here, but we have a number of faculty from UC Riverside that are leading this effort. We'll talk about them, a number of graduate students that are participating. We have a technical advisory committee that was set up through us in the Rose Foundation. So that's Tim Dye from TD Environmental Services, Michael Jarrett from UCLA Felding School of Public Health, David Howikamp, he's a former director of Region 9 for EPA, Elaine Shin from AQMD, and Jonathan Foster from ARB. Jonathan's right over here as well. And this does include organizations, UC Riverside, both the Chemical and Environmental Engineering Department and CSERT, which is a research center, as well as 4G Management and Emisense as subcontractors helping provide us guidance with the drones. Really, really briefly, all the people here basically represent CSERT. CSERT itself is the largest research center at the University of California, Riverside, by number of people or by dollars. It's a major operation for our university. The mission of CSERT, right, is to lead environmental education, collaborate with industry and government, drive technology innovation, enhance understanding of environmental challenges. This is an interdisciplinary approach. Right? We combine the expertise of air quality faculty, transportation, energy, climate change, all together to tackle the large issues that we face regarding emissions and air quality. And we do support UC's overall mission to align with the goals of advancing research, education, and public service. CSERT itself was started a little over 30 years ago. As it started, we had a little mantra of being the honest broker, where we basically have industry and regulatory agencies coming together with a university, providing fair, neutral research on helping guide the issues that face both industry and the regulatory agencies in achieving clean air. So for the team, so I'm David Cocker, Chemical Environmental Engineering at CSERT. Tom Eckel is just raised his hand for those in the room. He is one of our research engineers leading bringing the expertise for a lot of the field work that we're doing on board ships. Don Collins, to my right, is another air quality engineering faculty expert. We have Will Porter online. He is one of our atmospheric modeler, does deal with a lot of community, but also computing. We have Kent Johnson here in the front row, who is another field expert that's out there, is leading the drones. And then I have pictures of some of our graduate students here as well that are participating in this research. A little bit of background. Don't think we need to do too much of this background because I think we know why we are here. But the Port of Los Angeles and Long Beach is basically one of the busiest ports in the world, with over 15 million containers passing through each year. It's busy. It's putting a lot of demand on many, many different things in the port. Here we are ready to talk about the impacts on air pollution. It contributes heavily to a lot of the different air quality issues that have been brought up in the region, and the demand has continued to increase for better and better measurement out there, so that we can basically really move forward and do this. Emissions data, one of the big aspects of this work, is critical to understanding and quantifying the control technology on existing OGVs and the impact on the community, which we are going to measure directly. This is the superhighway of ocean-going vessels traversing the California coast. Obviously, this is the focal point of our study down here at the port areas. But there is a lot of movement, a lot of different vessels traveling through. I always think it's kind of interesting to put up the actual data because it almost looks like highways that are being traversed by the ocean-going vessels. So here again, the role of this project is to be able to understand what the role of these ocean-going vessels are. So when we think about them, so there's one with a nice plume showing. There are things that we call regulated emissions, things that are the focal point of many of the regulatory agencies. PM, so particulate matter, NOx. You might associate one component of it as NO2, or the brown that you sometimes see in the sky. SO2, or sulfur dioxide, carbon monoxide, carbon dioxide, and total hydrocarbons. These are either regulated at ambient sites, so they're regulated at the source. And then we have a larger area of all the other different types of chemicals and sources that come off these ships, which are going to be under the different emitted toxics that we will also be looking at here. So we're trying to take a holistic approach with this study. So that's kind of what's unique about the current one. We are going to be making measurements on ships, in the plume, using drones, in the community, measuring air quality samplers. We brought you a few pieces if you want to take a look at the end of this for those present. And then we have our computing side, or for our air quality model. These four things are going to come together to give us the best look that we can of what the impact is of the ocean-going vessels in your community, and provide those the information necessary for you to continue to move forward in achieving clean air goals. So study design, we had to write it up there, by land, by air, by sea. Right, we're hitting it from 3 different areas. And as part of this presentation, we're going to show you our 4 different major parts. Our community air quality measurement campaign. We have our emission measurements that we're going to take on the boats. We have our emission measurements we're going to take by drones in the plume. And then we have our atmospheric modeling to help support and guide the work that we're doing. So I'm going to start off with the air quality management campaign. Here, our goal is to measure fine particulate matter and multi-phase toxics daily, that's key, daily at 3 fixed sites for a period of a year. So we're going to get to all the different seasons, all the different types of conditions, and understand what is coming into the community at the fixed sites. This includes a highly detailed chemical characterization of the particle phase toxics, the gas phase toxics, as well as providing what we call fingerprints that we're going to use to help identify what the role of the ocean-going vessels are compared to the many other sources that are also present here in the port that also impact air quality. And the idea here is that we'll provide the foundational data necessary for estimating health impacts from inhalation of the airborne pollutants. I need to tell you what is really there. So for monitoring site selection, the way that we've been looking at this is that we've selected a number of different sites. We chose them by population density, so where people are living, the wind patterns of the port. See over here, and some of the models of all the different wind patterns we have at the port, as well as site security and accessibility, basically where we can easily go, right? So that we can be able to maintain these samplers in a environment that's secure. As far as this goes, based on these criteria, we have 3 sites that we've chosen to meet these project goals. These sites, indicated with the triangles here, allow us to capture winds arriving from the port under different weather conditions, helping us to understand different key pollutants and their patterns in the area. We're going to use a number of different materials to capture these emissions. Again, for those that want to touch them later, we brought them in here, but we are going to be collecting on Teflon filters, quartz filters, these sorbent tubes that are going to stick a bunch of gases to them that we can bring back to the lab. We're collecting on XAD4 resin. This is zoomed in. You'll see a little powder over there, as well as on DNPH cartridges. Lots of different media is essentially the take-home point. A lot of different media gives us a lot of different signatures of what's present. We have 2 sampling systems that we are going to be putting out at each site. One is a high volume sampler that is for the larger molecules, and a low volume sampler for some of the lighter gas phase toxics that are present. So we'll basically have two sampled systems co-located together. I'm not going to go through the list. The point is, this is a partial list of some of the toxics that we are going to be looking for in the community. From trace elements to carbonyls to all sorts of different species that would be present. We're going to use a whole suite of analytical instrumentation to be able to do this work. So this one here, I guess I should use the pointer there, is going to look for some of the gas phase toxics on the tube that we have. This is for a different set of gas phase toxics. It's HPLC. We have for ions that are present, so sulfates and others. We have for elemental carbon, organic carbon. When you picture diesel smoke, black, okay, that's going to measure for that, as well as a mass spectrometer that is going to be measuring for some of the larger molecules, toxics. So, like I said, I'm going to start and stop as we go through. So this is your first opportunity for questions. If you're online or here, haven't had a chance to check in, please click that QR code. That's how we're going to get the email address to send you this presentation. We're going to get a chance to ask questions, or if you like, you can scan the code to leave comments as we go through as well. Yes?
I wasn't able to tell by the slide, say, are the monitors in San Pedro? The community monitors, where are they?
So, all right, that's in
Terminal Island? Or?
No. This is in the San Pedro community. Yeah, this is in these are all in the communities. But this is in the San Pedro. This is a little bit further inland, right? Because we got a lot of different wind patterns that are coming, and this one is on the other side of the port. Yes.
Measured for, I can't remember whether
PAHs. Yes.
Okay.
Absolutely. This is the gas phase pHs are being collected on this. The particle phase pHs are being collected over here, and this is a partial list of the pHs that we will be looking for.
Is anyone measuring for those now? And those are cancer, the ones that I hear about lately that are.
I think interrupt really quickly. I'm not sure that people online can hear the question, so you might want to just quickly repeat it or summarize it.
Absolutely. So the first question was if we were going to be measuring for polyaromatic hydrocarbons or PAHs. And the next question, if you don't mind. Oh yeah, the first question was on the location and whether any of the locations were in the San Pedro community, which one of them is, and then.
I'm asking if they measure now, if anyone is actually measuring PAHs now.
Right, and then now the current question is whether anyone's measuring pHs now. The best program for measuring the pHs that I would refer to is called the MATE studies, which is the multiple air toxic exposure studies. That's been run by the South Coast Air Quality Management District. We are in the middle of MATE 6 right now. We being the general community, not me, is in MATE 6. At the MATE sites, they are also detecting on a weekly basis what is many of these pHs and other toxics. So we will be comparing some of the results that we have from these sites to what's going on in the MATE 6 program. Joe?
Yeah, thanks. I think I've asked this question before and you probably answered it, so I apologize. I don't see ultrafine particles on this list. Oh, under PM components?
Yeah, so the question being asked was whether ultrafine PM was on here. We are doing a PM 2.5. So we're using PM 2.5 impactor, and that PM is what is being broken into the many components that can be seen on the current slide that's up.
And the other, I do think that South Coast has finished collecting the data from MATE 6. They just haven't made it public yet. So
right.
I don't think they're actively monitoring for that.
Correct, but I was asked the question, have people done it?
It's coming sometime.
Yeah. Yes,
And last question, those are novel collecting sites. Did you consider putting a collecting site co-located with the historical measuring sites for?
we did consider that, but we really wanted to broaden where we were getting measurements from. One of the three sites, the northern of those sites, is actually fairly close, but not adjacent to one of the main sites up in the Wilmington area. Yes?
Yeah, this is exciting, it's every day, and so I kind of have two questions here. One is, there public access to how this is, the results are developing daily? That's my first question.
That's an excellent question. So one question is, will there be public access as the results are developing daily? Many of these more detailed analyses take a while to get through. So while we'll be collecting the data, they'll be coming back into our laboratory, and then they will be sort of processing through. Some of them will be available earlier than others. I think that's a really good discussion point for how it is that we want to be disseminating this information. And if you don't mind, I'm going to hold that one for detail more toward the end of the presentation.
My
Yes.
second question is, this is exciting too, the goal, it's a lot that you're saying, so I'm kind of like, trying to absorb it all, but, one of the goals is providing data necessary to estimate health impacts,
Yes.
from pollution. I think I got your words more or less right there. So how is that gonna be, done? I mean, the idea is, okay, that'll become public, that knowledge, and then whoever can use it to fight for public health will do that, or is there some direct channel to public health?
All right, so the question is on how our collections are relating back to public health. So here, again, this is just a partial list of identifying what's present. But as you're going to see as we go through the couple of the different steps, these and others are going to be used for several different pieces. We're going to be able to use this to identify where it's coming from, which is important, right? To be able to identify the role of the OGVs as far as their impact on the community. Each of these do have risk factors associated with it, but we are more focused on identification of this information and being able to relay this to the entities that can best use it when we go into the public health arena.
David, just one question online, okay? So this is from Elizabeth Mendoza at Card, and the question is, are there specific markers or tracers that would be looked at to tease out the ocean-going vessel emissions versus other emission sources of the fuel?
So right now we are more focused on using some of the chemicals that are present in the. I am sorry. I got this is an online question about whether we have species in mind for markers for ocean-going vessels. One of the things about most of the main engines of the ocean-going vessels, when we've tested them, is the signature looks a whole lot more like the lubricating oil that is used in the vessel. So it's a very large organic signature, and we're going to be targeting some of the signatures from the lubrication present as part of this list.
Here I go, one more question, actually two more questions. I want you to get to the rest of this too.
Mm-hmm.
If I look at your list, I see chromium there. Is that total chrome or is that hexagonal chrome?
That's total chrome.
You might want to explain to people why hexagonal chrome is a lot more difficult to measure.
So I have a question here about the chromium in the first column, second from the bottom, whether it was chrome 6 or total chromium. The technique that we are using will collect for total chromium. Chromium 6 is the one that is known to be extremely toxic, but the method that we are using is really going to just give us the metal signature. The metal signature is really what we are interested in being able to use as part of our identification of the many sources that are coming in. But the analysis of chrome 6 requires its own special technique.
Not a lot of money. What about detection limits for all of these things? Are you gonna be able to provide all that to folks so we know what your detection limits are?
Yes, but I didn't want to get into
No,
that
you
much
don't need them now. I just
detail.
wanna
Oh,
make
yeah.
sure they're available.
And the question is what the detection limits are for these. They are available, yes.
Thank you.
So we just recently had an incident with a battery fire. And I know that those fires produce cyanide. So my question is, will you be able to measure for something like cyanide, which we've already had an experience with here, through the burning of that ship, contents?
So the question was about cyanide and whether we will be able to detect it because they've seen cyanide from battery fires from a ship already in this area. Cyanide is not actually on our target list. I need to go check. It's possible that one of our analyses will be able to see it. I have to check. I've not looked into cyanide, but we will definitely check. Yeah, perfect. Sorry, I'm making sure we're getting notes down on that.
Could you be more specific with the three locations? Did you know the addresses or the streets or?
We debated going. So the question is what the exact location of the three
More or less?
sites are. We went back and forth on listing them out. We'd rather our samplers not be visited. So we sort of decided to not put the address out.
Okay, what keep you safe? Okay.
I also have some experience, when I was doing a similar type study in India, we put the sampler out. A lot of people were very curious. They came on up and they were smoking.
Okay.
We did recognize the signature later, and
So
immediately.
maybe one in Pedro, one in Wilmington,
One in Pedro, one in Wilmington, one over by Long Beach.
Okay, thank you, that works.
All right. So the second part of this, I'm sorry, I clicked too many buttons here. Is to talk about the emission measurements we're going to be taking on the container ships in the San Pedro Bay. So here we have a couple goals. One is to measure directly from the stack the fine particulate matter and the multi-phase toxics from 3 vessels. By being at the stack, we have the enough sample to be able to get excellent chemical profiles of the vessels as they're operating. And they'll be operating near the ports of LA and Long Beach. So we want to be able to develop a detailed chemical profile as they operate in your area. Provide baseline testing for the drones work that's going to be conducted. So this, by being on the stack, this is what's normally the more certified method for collection. So we're going to be able to now compare between the vessel and the drone. And chemical profiles from ocean-going vessels are extremely limited. In fact, I believe we are the only ones with chemical profiles from ships right now, and we're going to be getting more as they operate in the port. Yeah.
You guys are great.
So just as an idea here, we sampled over 40 different maritime sources, so we know what we're doing is we're going on these boats, and we have access to these boats to be able to get on them. We've deployed duplicate systems in numerous sources in tandem. That's going to be important in just a moment. We've gathered the activity of the different sources, right? You have a main engine, you have auxiliary engines, you have boilers, there's all sorts of things operating on these ships. And we are familiar with collecting the full spectrum of toxics in the field. Why are we doing this? I had to put one slide up here with some actual data. This is showing a vessel that we traveled on. So you'll recognize the California coast here, right, where we are right now. And these are measurements of the emissions of NOx from the vessel as it traversed from Oakland to the port and then out to Hawaii. We're only showing obviously the very first part to Hawaii. Down here, the blue is a vessel operating pretty clean compared to normal expectations. And then you can see as we get to the Channel Islands and enter your port area, the color changes dramatically. Those emissions go up 7 to 8 fold times. And that's why we want to see what's going on in your boats as they're operating near your community.
Can you explain that, why you think you're fine with that with your 3 vessels?
Can I wait till I get through these few and then
I just,
Joe has a burning question in the room, and
yeah.
I'm going to, oh, you know what, I'll do that right now. So the question was about the tier 3, not tier 3 vessel, what's actually happening here? The vessel we are on is considered a tier 3 vessel. Those are considered to be the cleanest fuel burning vessels operating in the area. Tier 3 is an emission tier. With that, the vessel has SCR, which is a type of control. It has EGR, and they are certified to operate at emissions in the blue. When you come to the port, the ships slow down, their power diminishes, and they are actually operating what we call off-cycle or different parameters than they're regulated for. Because of that, the engines themselves no longer are required to meet basically the blue color, and you see them elevate to the red. And it has to do with the fact that the engines are slowing down, they're cooling off, they're extremely low power, their emission control systems no longer operate. So again, we want to capture this as is happening in your community for the wide range of species that we have, and then with the drones that we'll get into, be able to capture what's going on as well. As far as vessel testing goes, we are planning to board and measure 3 different cargo ships that are en route to the port, and we'll measure it into and out of the port, or at least into the port, so that we can, and out, as they traverse, they go through their different operations. Again, the ships are slowing down, their engines are operating at a very low power. But that's when we saw those emissions go up. The goal here is to be able to measure all significant sources at once: main, auxiliary, boiler, for fine particulate and for multi-phase toxics. And it's basically designed to maximize the information value for the residents in the area and be able to tie into the drone measurement and the community measurement systems. We are going to be on board with basically miniature systems of what will be in the community, and doing the tests of the mains, auxiliaries, boiler. At least one of these tests is going to be conducted in tandem with a drone, so that we get direct comparison. So essentially, it's always fun to throw a couple pictures up. This is what it looks like when you actually go on a ship and start measuring from the stack. But this hopefully gives you the image. We're on board, right above where the combustion is occurring, and identifying what's going on. So as promised, another break for questions. Yes?
So the drones will be collecting in the area where is red, say the red zone area that you described earlier?
Yes. The question is, will the drones be collecting in the area that showed the red from the previous slide? And the answer is yes. And we'll be showing that a little bit more in the drone portion in a moment. All right. That's right. You'll have plenty of time later too. Go ahead. Sorry, I have another question.
For the vessels that you're testing on, are they all tier 3 vessels, or I guess like?
No. No, they're not all, yeah. No, because we need to be able to see older and newer. Because that's unfortunately the mix that you do have coming into the port. Sorry, for online, the question was, are we measuring all tier 3 vessels? The answer is no, we are going to be measuring a mix of older and newer vessels, technology.
Can I ask a question?
Yes.
That being said, is this red zone versus blue zone a phenomenon with only tier 3, or is this all the ships burn dirtier when they're slow?
A little bit of both. The tier 3, because the emissions have been reduced so much on a tier 3, when they pop back up without their controls, you see a much larger jump. But in all cases, the ships are operating at a much lower speed, off their optimum loads. So the emissions are expected to go up on the older and the newer vessels alike. Just the magnitude of it is larger on a tier 3. Yes?
I'm sorry, I don't know if Joe got this answered or not. Are you going to be actually measuring for the nanoparticles as well, the diesel?
Yes.
Okay.
Yeah, that's the fine particles are
The 1.5?
2.5.
Yeah, but so not 1 point.
On the vessel, they're all below 1. Officially, we'll have a cut of 2.5, but when you're on the combustion, the size of the particles are extremely small.
Yeah, I know.
Yeah.
But there's no way to measure those?
The P,
So just to add some clarity there, while we're on board conducting sampling for toxics on various types of media, even though we will be doing some size cutting for PM 2.5 versus larger soot, which is a different conversation, we'll also be characterizing the emissions from the engines with an SMPS for particle size there. That will give you a better understanding of where the distribution of particles under 2.5 lie, and ultrafine blend specifically.
Goes from like 3 nanometers up to about 1 micrometer.
Yeah.
We'll have Zoom, we'll have Zoom.
yes,
Hey, David, if I could just interrupt with a question online.
yes.
So this is from Christian Tapia. Is the study only tracking vessels using conventional bunker fuel? Any emissions testing of dual fuel capable ships? It'd be great to analyze and compare emissions.
I'm sorry. So the question is whether all the testing of the ocean-going vessels is going to be with the bunker fuel, or whether we'll be testing some dual-fueled ships. So I mean, even the example of the tier 3 vessel that came in was used bunker way away from the coast, and that's when we measured it, as well as a marine distillate near the coast. So we are seeing some of those, but there's a lot of types of dual fuel. I've got another one of my engineers in here.
Short answer to that would be yes.
Yes, he just told me keep it simple. Yes.
Yeah, because I don't think that they can hear Tom. I don't think the people online can hear Tom with the answers.
But that's what. Yeah, that's what.
And there was a follow-up to maybe repeat the answers about the PM 2.5 versus ultrafine particles that you did.
Fantastic. So the question was to follow up, to repeat the answer on the PM 2.5 versus the even smaller PM1 fraction. We were noting in that, yes, we are going to be getting a PM 2.5 cut, but we will also be getting size distribution, or the whole range of particulate in the PM1 range, which will tell us how the vessel is operating, what type of particles are being released in the sub 1 micrometer range. And then, I'm sorry, she had up, nope, in the middle.
Yeah, I guess for the air quality study, it was like over 1 year daily testing for the vessels. Is it multiple trips per vessel, or what is like the?
It is, so the question is in the community, every day, for a year, long-term, at these 3 sites. For the vessels, it is a one-time on, one-time off type testing. It's very hard to get access to these vessels, and the testing is rather intense while we are on them. So we will be getting them as one time as they're coming in and out of the port area. It'll give us many different operations, a couple different fuels, all sorts of different characterization, but we will be hitting those vessels one time. Yes?
It's just related to that. Okay, where I live, I see lots and lots of tankers. And they sit there at anchor, I think, for days. I was told by the man that runs the marine exchange, he said they sit out there until the price goes where they want it or something, you know. Yeah. But, and I like to go to the beach. And I look and I see that, I started keeping track of them. They spew black soot, you know? And so are they gonna be included? Because they're not moving, they're not going in and out.
So that's where the other portion of the study comes in. right, with the drone. So really our goal here for these 3 vessels is a very intense, high-level chemical profile of the ships where we can take in as much stuff as we need to on the ship, collect for roughly as long as we need to be able to get the detailed information that we want. We're not going to be doing that on a tanker that's out idling around. We won't necessarily have the access. We need to be able to get on, come on in, and be able to go back out. However, that's only part of how we were measuring the ships. Right, the next part is really going to be on the drones. And so I'm going to go ahead and move into those drones. Actually, I'm sorry, there was another question before I do that.
Just trying to understand fuel type and fuel usage, like how are you going to decide which type of ships, in addition to bunkering fuel, like are you looking at methanol, and how will you indicate that the type of ship and the fuel type?
For the 3 vessels that we are doing.
Only 3.
Yeah, for the 3 vessels, right, these are going to be more conventional fuels. But the idea is that with the drones, we're going to be able to hit a much wider swath of different vessels as they enter or exit the port. So I think that gives me a perfect segue into bringing up Dr. Ken Johnson, who's going to be talking about the drone measurements.
Thank you, Dave. Boy, a lot of good questions. I got the easy job because it's so much easier to talk when I know what you're asking. Our goal is to capture a lot of what you've been asking. You know, how do we know what the range of equipment that's coming through? When is it leaving? What is it doing at anchor? What fuel is it on? How do we know what it's doing? As Dave said, you know, at UCR, we've been measuring on these ships for since 2006. And we've measured maybe 30 or 20 on big ocean-going vessels, maybe up to 40 when you think of some of the marine. We're hoping to do over 100 with the drones. I'd love to see if we can get 300, but I can't promise that. But we're going to be there for a year. We set up this really neat idea where we could be in and out in 15 minutes. It takes us months to get on a ship, from security to the logistics, to climbing on board, setting up our equipment, moving to the ports, actually working with the ship, collecting those samples. It's really a lot of work, but it's high quality data. You can't do one without the other, but you can't actually figure out the whole distribution without the drone. So we've always had this, like, how do we do this fast? A lot of people have measured with drones, and we bought a system maybe 4 years ago, real basic. It just gave some gases. It wasn't what we wanted, but it really serves the purpose of why drones exist. We really wanted to think of a way to do it better, and that's where, you know, some of the research Don Collins has been doing. He had been doing grab samples to collect this in a volume and do the analysis on the ground. And really, it was a light bulb moment for us, because it's like, wow, no one's really thinking about doing it that way because it doesn't really achieve the desires of what people are doing with real-time plumes. Most people are trying to look for NOx and SO2. They're looking, are you complying with the fuel? Are you complying with your engine performance? But we're trying to look at exposure to a community. And those 2 things aren't necessarily as critical as the PAHs, the PM, and what's happening. And, you know, when you look at these plumes, I mean, I think this is your picture, right, Janet? Yeah, so we'll give credit to Janet. You know, she goes out there and she sees things that happen, and it's great because you have a ship starting up and getting going, and you have a ship exiting. So these are 2 cold start examples. And what happens in a cold start, you got these massive pistons. They've been off, so they're cold. And you start moving that with combustion, all that oil is leaking by because the rings are not set. And so all that combustion is happening right there. And it's 1 hour. And where is it happening? In everyone's community across the world. Where are these engines certified to work well? On that little line that goes between LA and Oakland. We don't think about where we live. And it's not that they're doing it on purpose. Let me just go back in history. The light duty vehicle, it had to figure it out. Then the on-road truck, we're in the 2nd regulation right now. We're finally getting that figured out. Locomotives don't have it figured out. Stationary sources have it figured out, and shipping is last. The biggest engine, unfortunately, it's by port community. So I think the discussion from this study is really gonna, I think, go around the world and maybe have an opportunity to make change in that area. So we really wanted to think about how could we get in there quickly. So this is the actual drone that we're going with, and our drone group here is Kevin with 4G. They have a company where they can fly. They have all the pilot and the licensing. He was a former Coast Guard, right?
Yes.
Yep, and worked with the port. Was also on one of the terminals as well.
Yeah.
Back in the day.
Retired from the terminal.
But anyway, we're going to replace, instead of delivering packages to the vessels, we're going to deliver emission measurements tools. I think we're calling it, what was our name? The good name we came up with, Janet?
Carbon Hawk.
Carbon Hawk. Yeah. So you asked about where. So this is the area that tends to be at anchor, and we really want to capture what's happening as it's leaving the port. And then if we have a time, we do have an option to have a floating barge, so we can travel out to them sitting at anchor, fly up to the plume and back. It takes about 20 minutes.
Actually, the picture that you showed up there, it's even more compelling because the MS ship is inbound. That's not a cold start, that's inbound, so that shows you when
wondering if it
it's
was just
working.
angled and then it was going to
Yeah.
pull around.
No,
Okay.
that's heading to Yangming.
Oh, that's
So-
right.
Yeah, so that vessel right there is working at about maybe 20%, and that
Oh, less than that.
maybe 8%, you're right.
It's around,
Right. So
it's either 5 or 6 knots,
Right,
which
and
is
then
way low.
the cruise ship is a cold start,
Yeah.
right? So,
Yeah, and so what Kevin was saying is the ship that's in the slide for the people online looks like it's heading in, so that's actually a hot engine cooling off, going into its port, just to show you how much the emissions increase. Yeah, and this is happening 12, maybe 15 times a day.
and that ship, that MSC ship has an SCR and a burner, it's, you can see it in the stack log, right?
Ah.
Yeah.
So one of the things that we developed is, or we're developing for the sampling, is shown in this picture here. Instead of taking the drone up to the stack with sensors that are mounted to the drone, we're going to take this volume up to the stack. We're going to engage a little plunger. We're going to suck it into a chamber. It's all metal. We're going to bring it down to the ground and then put it through analyzers. Way too heavy to carry up into the sky. We are so focused on looking at the health side of this, we're not looking at trying to make a simple drone. So we went from a little drone that's about this big. I think the drone we're looking at is a 10-foot wingspan drone. It's called a heavy lift. And this is, right now, we're trying to get this under 40 pounds, but we're struggling. And then this is like a 12-foot pole. And then these are going to be our probes for sensing. So we're going to get into the plume. And so if you think about this area, we're going to kind of fly really close and then track where that plume is. And then you'll see what we're doing. And we do want to try to look at what's happening at anchor. I haven't seen them smoking when they're at anchor, so that was a really good thing to hear. This is the work that we have done in the past, so we're kind of combining thoughts. We're not creating anything new, except we're pulling it together to make it new for drones. So in the past, what we would do is we would fly into an area that we knew that had emissions. We would start filling the sample. We would fly vertically up, and then we could characterize the emissions as a vertical column. It worked really well. We're going to take that same idea, except we're going to stay in one location, and instead of it being in a long cylindrical tube, we're just going to put it in one big volume, and we can collect it very fast. And I'm going to show you why that's important. Any questions before I go on? Yes, I love questions.
What is the rules for flying a drone near a ship? What is the rules for flying a drone near a ship? Do you have to get permission from the ship?
So let me re-ask the question, and then what are the rules for flying a drone next to ships? And so one of the
So,
audience members is going to
the first
answer.
thing we need to do is go get permit from the port, whichever port we're flying out of, we have to get a permit from them. Then when we plan on, going up, we will put out, messages to all the vessels through the VTS system. And we'll make sure that those messages, they're called security messages, and they will go out to them, let them know that we're flying and testing, and we will be contacting them. Then we will contact them on VHF radio and talk to them and let them know that we're gonna be flying close to their ship, and we're sampling and kind of all that. That's kind of the process. It sounds easy, but it's not.
No, it
And
doesn't
there's a lot
sound
that
easy.
goes on, especially using drones and what's going on in the world. So
Now,
we gotta kind of walk.
as a follow-up question, is there anything they can do to adjust what they're doing so
Ah,
that
yes.
will affect the testing results?
So the next question was, is there any, so to answer her original question is, the pilots that we're planning on using do have the experience to work in the ports, and there's just regulations to follow. The follow-up question is,
Yeah.
is there anything that we might do that would alert to the vessels so that they change their behavior? I don't believe there is. We were going to alert them, but the ability to change what you're doing on a ship, it takes hours for that fuel to move and change.
There's nothing that they can do to
And
change anything.
yeah, there's no way to make heat to make the emissions look better. So I don't think there's anything they can do except to turn it off. But then they're going to be in violation of safety, so they can't do that either. But if anyone has an idea on that, let us know, because that's the last thing we would want to see happen.
But by the time they know we're there, it's too late for them.
Yeah, because this should be an alert. We're flying to your ship now. Yeah, be aware. Yeah,
The lights are on and it's too late.
yeah. So I think someone had asked, what about the ones at stationary? 2 years ago, I told you we had these drones. We were flying them around in the port. This is actually a view from our drone. We were flying to this stack. You can't see anything coming out of it because it's in what's called video mode. But when we turned it to infrared, you can see the plume real easy. And I just wanted to kind of give you a feel for what it's like to be on a drone and flying into these. This is what it looked like on the Coast Guard vessel. We actually worked with the Coast Guard, so we do have a relationship with them. We had EPA law enforcement there, and the Coast Guard, and then UC Riverside, as well as CARB. Elizabeth was on this one. So you're normally maybe 200-300 yards away, sitting here on the vessel at the rear. You can't see which stack it is. That is our drone right there. This is the actual pilot. This is called a spotter. And so this is all required by law. And so we will follow the law. We will have a drone pilot with 4G. We'll probably have a spotter, which will be with UCR. And then in addition to this screen, which is going to be showing the stack, we're also going to be having something to identify the plume. And that's very important. This is the drone we used. It just came with this really kind of low-cost measurement system, relatively accurate, but we're only going to rely on this to find the plume, but not to make the measurements. Very limited to just a couple gases. You can't bring particle mass instruments up there, especially nothing for PAHs. So we were talking about how easy it to see these plumes. This is an infrared camera. We bought a really higher end one, so this was like a 680 by 480 resolution camera. We're now at 1280 by 1280. We could have gotten even better if we went with Chinese, but not available. Turns out though, that was a blessing. The drone we ended up selecting had an open source electronics, and we're able to actually overlay our video on the controller screen directly. So we won't need two screens potentially. Very nice that we can actually have open source and really nice communication with our drone manufacturer. And that's the port in the background. This is what the data looked like when we were testing. It's very, very difficult to stay in the plume. So you can imagine this, like the plume is the size of this table, and you're 300 yards away and it looks like a little dot. And you're trying to fly a little stick in there like this. And I'm trying to tell the pilot, go up. And then all of a sudden the number goes down. So I said, go down, and it goes down worse. Go back up and go in. So we had a hard time keeping the signal in there. But even with that, these were the three. So I did 4 ships in a matter of 3 hours. It only took me a while because I didn't know where to go. This is the first time we're doing it. Let's figure this out. But really the slowest part of this is transiting between ships. But the actual measurement, I was able to get 3 good measurements, 5 good measurements, no good measurements, and then about 5 good measurements. Our sensor broke, it just like stopped working. And then we got it working. It happens. It's just tell me it happens. The key is, once you're in the plume, trying to stay there. Because I was measuring it in real time, I had to stay there for almost like 90 seconds. That doesn't seem like a lot of time, but it is. And so with our new system, how quickly were we gonna try to fill that volume? We were gonna try to fill that volume in 15 seconds. So the goal is, we're gonna get in there, we're gonna identify it, we're gonna say, does this look good? So we'll go up, down, in, out. Yep, I think we're in there, trigger it, and then we're done. 15 seconds versus months. And that's why you need the quality of the data from Dave Cocker and Tom Eckel. And then you need the volume of the data to figure out where does that really fit in. And so the main key is gonna be, how do we get that signature? What species should we really look at that would be representative? So with the community monitors, and we see what we think is from ships, then from the ship testing to say that, yes, that's really from the ships, and then our measurement system will be tailored to make sure that it measures those things so that we can capture over that year that really high volume of ships. And we're not gonna measure a ship once. We can go up, down, then back up and down, and then back up. We could even get, as it's heating up, we can get all sorts of things from it. I did want to talk about our team, having experience with the port. We already had discussions with the port authorities that conduct these. I worked with Rose at the ports of LA and Long Beach just on how we could interact with them to keep them aware of what we're doing. I've had communication with the Coast Guard. At the time, we were going through a lot of turmoil with the Trump administration. So he had to terminate that conversation with me, but I'm now back open. It was mostly because they were so focused on border control, they couldn't afford to have anyone talking outside of that. But they've got that under control now, and we can communicate with them. We also have, again, I keep pointing at 4G, this 150-foot barge, which is an option so that we could take off and land from a portable application. And from what we're hearing is that might be the easiest way to do it than doing it from land, because you can make the distance much shorter versus from a land base, you'd have to fly all the way out to the vessel, sample it, and then fly all the way back, hoping that you put your drone in the drink. Our drone doesn't have a lot of technology on it because we are just capturing, so we could put it in the drink, minus the drone itself. We do have 2, and the camera.
You had to say that.
I had to say it, knock on wood, but yeah, so that was the last slide for me. But I think there was a lot of good questions. We've been measuring emissions for so long, and I think what's neat, this is the final frontier for emissions. Really, once we get to the ocean-going vessels, it's really the last source that's hard to fix. But the more we can talk about this, we have a great relationship with Wärtsilä and MAN, and to be able to nudge them with good community direction without needing a regulation, because if companies like Maersk decides that they want cleaner engines and we give MAN a different way to get there, maybe it sets the stage and maybe we don't need a regulation. Because these companies have an image. Now, not everyone thinks that way, but I think there's a way to get it started. They were willing to switch fuels when everyone else said they could never do it. CARB made the fuel rule change, and Maersk was able to try it before everyone else, and it worked fine. Everyone thought the engines wouldn't work. MAN said it wouldn't work, but it did. It's just we resist change because we think something's going to break, and it's a very different thing to manage. But I think when we see the importance of this, I think it's going to be very clear, and I hope that we could do this in other ports as well, and maybe repeat this every once in a while to see how things are going. Because once we have this all figured out, the cost to do it again is way less. I mean, we've been doing this for a year, and we haven't made any measurements. So, it does take time.
So just one question before we go to here. Christian Tapia asked if the drone footage is publicly available. So I think the question was asked when you were showing the photograph, so
Yeah.
maybe related to the older
Yeah, I could, yeah,
Maybe
it's a
then
report,
also-
I just submitted it to CARB. So once that is
So
approved.
maybe repeat the question.
Oh,
just so-
yeah, so the question was, some of the drone footage that I had on the previous testing that we did in about 2-3 years ago now, if that's available. I have a report that will come out. I just submitted a second draft to CARB, so I'm expecting it to go through in maybe a month or two. And then all of that video, I guess we could put it on our web thing, because it was really cool video. I was filtering in and out, so you could see video versus IR. We were flying into different drones. You could see us going in. We were getting pretty close to the stack. I think we were within 10 feet. So we won't get that close with this bigger drone, but I could get that close. And we were alerting them with bullhorns and radio. And people kind of came out on the deck, looked at us, and then went away. So it was nice. I was really pleased. I wasn't sure. Maybe because I had the Coast Guard, boat all around me. Hopefully we can let them know we're safe people. We're not. There's some bad things going on with drones right now. So yeah, I could understand apprehension. So yeah.
I just want to say that today is Earth Day, so
Ah.
it's kind of important. This is a great thing to hear on Earth Day, and I want to call attention to the fact that this was driven by community efforts and a group of environmental groups, that we came together and were able to use our funds as litigants in a lawsuit to bring this project about. And I think it's really important that communities understand that there is a way that they can impact things like these environmental damages by asserting themselves and standing together, and uniting and being intelligent about how we can face these dilemmas going forward. So happy Earth Day.
Yes, yes. So the comment was more about how the community could, in the presence of something that they see looks wrong, stand up and make a stand. And that stand generated funds. Those funds are what have us here investigating for the future. So nicely done. Yeah, happy Earth Day. Yes, sir.
And I thank the homeowners coalition, I thank everyone that funded this, and thank you for the presentations. On Earth Day.
Hey, you're paying me to be here, so that's all right.
Well, I appreciate
Yeah.
the funding. And I know, and very much I feel that.
Good.
Because I gotta say quickly before I get to my question, that since you brought up the fuels, which to me is the most exciting, the reason I'm here, importantly, as far as the community participating in our own protection, I think the low sulfur fuel rule that you mentioned, the first rulemaking in 2008,
Yeah.
and then the really good one in 2016, largely originated in the folks, some of whom in this room that pushed that through all the hurdles, as you said. There were technical hurdles. One of them in the end was fuel availability.
Yep.
So
Yeah.
back to
Remember
that.
that.
My question, I apologize. If I missed, but in the not drone survey, but in the shipboarding survey, is that 3 ships, did you say, and they're gonna be random, right, as to fuel type and tier? It's gonna be whatever they are.
It will be whatever. I don't know if you have it already selected, Dave and Tom.
Right, I wouldn't call it random.
Yeah.
Well, I mean, you
Well,
won't
we
pick
are-
tier 4 or tier 3, you'll pick what's,
We are going to pick across the tiers.
oh,
To try to get one of each.
Because it's only a small,
yeah, it's only 3.
right, but only a small
Specifically,
fraction
we're
is.
prioritizing getting 1 tier 2 and 1 tier 3 diesel vessel. Regarding fuel or not.
No, we'll be going, we're not there yet.
Oh, sorry. But yes, 1 tier 3, 1 tier 2, prioritizing diesel because that's the
Okay.
most common type of vessel.
Got it.
The most common fuel we see. Third vessel, we will, since it comes, if we can get another tier 2 or if something that's got alternative fuel is available, we would certainly prioritize that over other options because we likely it's coming as opposed to just what's here.
If only we did have them come in here, which takes me to, okay, so now the drone, that's gonna be the ships that are coming in, right?
Yeah.
Whatever they are. And so with that, will you be recording the tier level for the data you're capturing associated with each ship? Will you record, you can tell if it's a tier 3 by this?
Not really. So we'll get the IMO number and then
Okay,
we'll
and then
work
you'll-
with the
Great.
data sets.
So
Yeah.
you'll have that link?
Yeah.
Because now to the dual fuel, but also potentially when we did have a visit from Melvin, I think it was.
Yeah, I was there. Yeah.
Great, but now we're back to, it's uncertain, I believe, even, and so LNG, there are a lot more of that direction, actually that's back in the, on the top 40. So going forward, I'm hoping you can apply this to capturing the data on the different fuels, because we're looking at tomorrow as much as today.
That's a great point.
So knowing which fuel, which tier, and what you may be getting in the future, LNG maybe, compared to methanol, compared to ammonia, if you're going to be able to capture that, that would be great.
Yeah, and so the comment was really about how fuel plays into the research that we're going to be doing. And just to remind everyone, we also have a contract with CARB, and we just completed testing a biofuel tanker. We're testing next a renewable diesel, and then after that will be a tier 3 tanker, and then an LNG tanker. So we are doing that work. It's just not within this contract, but we have access to that. So all that data will be available to be shared in that report and also easily through this contract. So.
Right, and we've already tested an LNG as well.
Yeah.
With SCR,
For the 2 vessels that have already been selected for the onboard sampling, are you, and I know it's like a 100 question on these 2 vessels, but are you able to share, aside from them not being tanker vessels, or reefer vessels, dry bulk, container, ro-ro, anything else about them? And also if you're able to share the multiple carriers, or is this?
So we are talking to multiple carriers with multiple vessels, and part of this is lining up the testing with when we will be on the drone as well. So we can't get the vessel yet until everything's aligned. Right? The drone's coming south soon.
Yeah.
We will be starting to look, but we've looked at many different lines. We have a lot of different connections to be able to get all the different vessels. But we're thinking big container. So generally.
Joe Lou, and then we'll come to you.
I've been hassling you about this issue a lot, ever since you proposed to do the study.
Yeah.
But I got a little bit of a new take on it.
All right.
So one of the things that could be very beneficial from this study would be that if we improve the accuracy of emission inventories, right? And how best to do that is an outstanding question of whether or not it will make its way into that decision-making process of how those emission inventories get calculated. So the way that those emission inventories get calculated currently is that the ports contract out to a consultant, Starcrest I think it is, who does these inventories for them. Then they take that inventory, they hand it over to South Coast Air Quality Management District, who sticks it into their air quality management plan, reviews it, blesses it, sends it to the Air Resources Board, which reviews it, blesses it, puts it into a state implementation plan, sends it over to EPA, who reviews it, blesses it, and adopts it into the Federal Register, and it becomes part of the plan to reduce emissions. So in order for you to be able to make this study as effective as possible, I would ask you to talk to the folks who deal with this at Starcrest, the folks who are dealing with the emission inventory for the AQMP at South Coast, the folks at CARB. I don't know if you can talk to anybody at EPA Region 9, but them too, just so you can tell them, we are doing this study. Is there anything about this study and the data that we intend to produce that would be more useful or less useful, depending on how we pull this off, so that you can make sure that your emission inventory is accurate? Because that one map, I hadn't seen that one map before, where it actually shows what happens when the tier 3 turns off its control equipment, is exactly what we're concerned about in terms of the accuracy of emission inventory.
No, well said. I mean, I don't think I can repeat all that question, but, yeah.
What I'm going to do though is we have one more section, so I'm going to get to it and we can revisit any of these sections in the final recommendations and questions area. So thank you, Kent. So the last component of the study here is really community scale atmospheric modeling, right? Because we're measuring the vessels, we're getting the breadth of data available from the drones, we're in the communities, we need to be able to tie them all together. So as part of this, one part of this modeling was already done to help identify the sites to be tested. But the idea here is that we're going to utilize what are called forward and backward models. Forward, meaning from your source, your ship, to the community. Back trajectory, meaning we measured in the community, where did that air come from? All right, so we'll look at forward and backward models to link the measurements in the frontline communities to the ocean-going vessels. We're going to use the stack data, the drone data, and the community measurements to guide and constrain the modeling efforts, because we will have measurements from each and every one of these. So we're going to be able to really train the model as best as possible. And then we'll be able to model scenarios that can be used to better understand the air quality benefits of various mitigation strategies. We've already heard several of them from the group today related to ocean-going vessels. All right? But we need the model, because we have to keep in mind that air is constantly moving. It's constantly moving from all sorts of different locations. And so the air quality that we're going to get, right, is going to be based on where that wind came from. And in here, right, with the sampling site observations that we have to constrain things, we're going to let the model make the connections between the sources and your community. With that, I know this is not your community up here. This is, but we're doing your community right now. Is we're using high split, which is a model, so we can say that, hey, here's our site. So this might be one of our community sites. In the future, this is where all the different air patterns came from. Forward trajectories, again, are going to allow us to look at the other direction. If we had a ship over here, how the air moved to the community. The key benefit, though, is to help us understand and explain the observed air quality that we see in the communities and be able to link this whole study together. So we will be able to bring together meteorology, your wind patterns, your emissions, look at the chemistry and transport, and be able to identify, and obviously our focus is going to be right over in here, we'll be able to bring it all together effectively. All right. So that's kind of what's going on with the chemical transport models, is being able to then forecast what happens based on what we learned in your communities. When we talk about this, outcomes and community impact. So our project goals, again, one of the big ones is going to be to disseminate the information. We got to get it out there. We'll be using our scientific journals, of course, but we need to get it directly out to the community as well. So we can motivate the regulatory shift in the regulatory paradigm to prioritize public health in communities adjacent to the ports of Los Angeles and Long Beach. And this work, particularly the drones, has the potential for a new compliance verification for vessels as they're moving into and out of the port in use. So short term, right, we'll have a project, it's going to get you a report, the data, the findings, the recommendations. That we're going to be getting out to community groups and the Rose Foundation, and the community groups and the advocates here that actually made this project happen. We'll be getting the information out to the different regulatory agencies, partially through our scientific journals, but partially by the fact that we have communication with many of these different agencies. We've been working with them as well. You mentioned the low sulfur rule that came up. We were taking a lot of the measurements for what was going on with the high sulfur, low sulfur on the ships. We have these bridges, as well as a public posting on the UC Research Center webpage for a permanent identification of what came out of this work. Long term, right? The hope is to either help generate the new regulations necessary to improve the air quality in the area, or motivate the companies to do what needs to be done to help improve the air quality, as well as provide for potential new methods of regulation enforcement. So here's our diagram, putting together the pictures we've had from the different parts of the study, where you had your frontline community, your drone, the ship measurements coming together, combining with the computational analysis of our atmospheric modeling, producing both a technical report as well as our ability to provide press releases for what is actually coming out of the study to further inform the community, as well as the agencies that have the ability to enforce and drive regulation for our hope here, the blue sky. The timeline, the community sampling, we are expecting to commence next month. Brought you a little piece of the sampler today, but next month we should be out in the communities pulling your air every day for a year. 3 different sites. The drone sampling, expecting to commence sometime in the summer of this year. The ocean-going vessel stack testing is going to be conducted in parallel to the drone testing. So we're lining up the magic vessel that we're going to be able to do the comparison between the systems. The major next stage of the modeling will commence about 6 months after the start of the community sampling, once we start having these results pouring in and have a lot of different data to be able to work with to better refine and understand both how the air got to that, but also be able to predict the air quality impacts. The next major community update we figure will be in fall 2026, when instead of us telling you what we're doing, we're going to be telling you what we're learning. Right? That one should be far more exciting. Right? They'll see what's coming out of this, and then the program conclusion is expected for fall 2027. With that, thank you for your attention. So let's see what other questions we might have that pop up here. Again, this QR code is if you want to leave a comment for us for later to answer by email. If you haven't checked in, online or in person, give me another opportunity. And again, it gives us the opportunity to recognize the advocacy groups that actually led to the funding that's permitting this type of work to be conducted. So with that, I wanted to put that slide up instead. And I'm going to say one more thing and I can answer the question. We have an email site up. UCR port study at cert.ucr.edu, which will get funneled directly to the researchers in the study. We have a website that has just gone active as well that starts to talk about what's going on with the study. But you had a question?
Yes, I just want to make sure I'm understanding properly. I know you're onboarding ships, I think you said 3. You have
Yes.
a relationship with. But you're drone testing many ships at random or organically. Okay. I just want to make sure I'm understanding.
Yes. Right. So the few tests give us extremely high detailed information from the vessels through their operation. The drones provide us many vessels, many different fuels and technologies that's operating inside the port, stationary, moving in. The fact that there's a drum that's going to pull some samples, we're going to be able to get a snippet of some of these air toxics as well, back to the lab and tie it all together.
Okay, and then just to follow through on Richard's question, the because I had the same concern, is that really, there's two types of data being collected. There's the actual, the emissions, but also all of the circumstances by which you're collecting that. In other words, what kind of ship is it? Is it coming or going? How fast? And, what tier 1, tier 3, whatever it is, what kind of fuel. All of that also has to be documented along with the sample
That is correct.
in order for it to be meaningful.
Yes. So the comment was that when we're looking at these vessels, right, we're going to be getting speed, emission tier, all sorts of the key parameters that you would expect to get out of a vessel. And the answer is yes, we will be.
Hey, David, an online question, and it's about the involvement of community groups. So the specific question is, are there any local community groups involved in the study? But maybe if you want to talk about how, so I mean, if there's an answer to that, that's great, but then also maybe talk about how community groups could be involved, and maybe also how individuals, connected with a community group or not, can get involved, and what sort of information, what sort of feedback we can use.
You want to take that?
Oh, go ahead.
All right, so the question is, are there any community groups involved? Well, and then how can more groups get involved with the study? All right, that was essentially the question I'm echoing back. I'm pointing up here again, by definition, there's a number of community groups that came together to create the funding for this. I'm hoping they will remain engaged, since this is what they've created. So that's what we have listed up on the site, right, for our Coalition for Clean Air, ECR Communities for Environmental Justice, Natural Resource Defense Council, San Pedro Peninsula Homeowners United, and San Pedro and Peninsula Homeowners Coalition. Right, so these are community groups that are going to be involved. We've also reached out to additional community groups as well, from recommendations that we had from AQMD, who they knew were active in the area. We've reached out to the Impact group. That's what I was told they were called. Hopefully we have some online. So we're continuing to get the information out. The more groups that we know of to communicate these results with, the more outreach that we will be able to have into the community. There's additional community groups that will be involved, because there are certain places that we are sampling that those locales, there's an automatic community built into that as well.
Email address.
Yes, and we have our email address up. If there's any recommendations or thoughts on how to engage further with anybody that's online or present here, this would be fantastic, because obviously we want to have the broadest impact possible. We are working with this particular program to help the frontline communities here, but we want this to go well beyond what it is that we are doing as part of this project.
So what I'm listening right now is that you are relaying all this information to community-based organizations and non-governmental organizations as well. And then this information they will relate to community members. But I think my question is, would we be seeing community leads and community members in this type of gatherings? Like, are they going to be here? I don't know if the community-based leaders here, because I was invited here, but I think it's important for the community to be exposed to this type of conversations and listen all the different aspects of the people who are invited. Right,
and as is right now, we're hoping to get the feedback as we're going into this from our community leaders that are here. But as we continue forward, yes, the hope is that we will be able to disseminate and be able to actually work with some of the communities beyond just the leaders that are present. But that's going to be something that, again, as we get recommendations on how to do it. Any recommendations? Again, I'm going to point you right on up there, or to the QR code as well. We are also working Yes, and that's part of what we're hoping to get from our technical advisory committee that we have built as well, and how to best get it out to our community groups.
Just on that line, I wanted to say that it's important to give communities time to attend these meetings. So I think more time ahead of time, like a month or maybe even 2 months notice and reminders would be, you'd be able to reach more community members to come out. And even from my perspective in the state, you know, the short time frames and travel arrangements, like I was able to come here, but just barely.
Right.
And I think community members are also impacted similarly. So.
Right. For that fall piece, we can start setting up now for when the information can get out there, and hopefully at that point find a site that can handle a larger number of community members at the same time.
Meeting long enough, like one of the sites found, delaying the meeting so that people have enough lead time.
Thank you. We have a question in the audience?
Kind of a statement, David, and
We have a statement.
An opportunity for you guys to take credit and to link for people how this can be useful, because you have real world experience of having done something similar. I don't know if you were involved. I know Kent was the lead author on these studies, but back when the new diesel emission control technologies got deployed, Kent went out and took measurements of those trucks operating at low speed conditions here around the port and in other places, and he found that that emission control equipment, that very same emission control equipment that's on Tier 3 vessels, did not work in those low speed and low power operations. And as a result of that, the Air Resources Board amended how they calculate emissions profile for those trucks operating at low speed emissions, in fact, in their model and how they do that. That resulted in the agencies having to do more to clean up the air than they would have otherwise. So this is very similar, and it could result in the same thing. And I don't think you guys gave yourself enough credit, because Kent did these studies that actually had an impact in the real world, and this is what we're hoping is going to happen now with the ships.
And that regulation comes out next year. It's actually looking really good. Like, trucks are emitting what we think they should be emitting. Like, we finally figured out how to get it right, but we just have to keep moving it up the ladder.
Yeah.
And the ship is very different than a truck.
It's the same control.
But it's neat that I hadn't thought about the approach being the same.
Yeah.
Right? Start with the data, you start with the report that identifies the problem, then you look at the inventory, then from the inventory you say, oh my gosh, we're off. We're not getting where we need to be.
And what do we do about it?
What are we going to do about it? And I know CARB is working on a slow speed regulation right now, or it's kind of thinking about it.
Yeah,
I don't know where
in-transit regulation.
In-transit regulation. They got the at-berth regulation. In-transit's going to be hard.
Yes.
I mean, now you're dealing with a vessel detached from land. How do you do that? I don't know. There's some really crazy ideas, but
well, also the at anchor ships too.
yeah, that one is. I didn't know how you do that. They barge really work that much. Unless you think you can barge.
Yeah. So thank you. Yes, that's something that we've been working on as a center for decades.
Our whole life, yeah.
And Ken and I have been working together for 30 years with that. Yet I'm only 35. No.
I've been doing this for 35 years, man. I'm not just teasing you.
Tom, legacy going.
Are there any more questions online? Then what I'm going to do is I'm going to thank those that joined by Zoom, and I'm going to go ahead and stop that portion. For those that came, hint, 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 for future ones on Zoom, we have snacks in the back, and we're not going anywhere if you have some more questions. Thank you.
Did you see it? Troublemaker right there. Yeah. That's how we drive too, right?
Message to I'm the Zoom monitor.
Now, if I leave the meeting, it's not gonna shut down because you're the host, right?